Welcome back to Cradle to Grave Algebra. My name is Mark Gingras. Today we're going to talk about Venn diagrams and how they relate to sets. How can we visualize sets using a Venn diagram? And then we'll also learn how to plot these sets on a real number line. So bear with me. We're going to get through this and we'll just jump right in right now. So as you can see, I have this big giant circle that's over here. And I labeled it with the letter A. So A is not in that circle. I'm just making it so we can call it something. It's called A. And then I have another circle B, which is this circle here, and so forth. And each circle is within A. They're all inside of A. So imagine A is like a big bucket, and inside of that bucket we have all these other little buckets. Bucket B, bucket C, bucket D, and E, so forth. Now, inside of these buckets, I actually did put elements or objects or members of that bucket, mostly referred to as elements in mathematical terms, so we'll call them elements. And what I did was I wrote these elements down as a mathematical expression. So A is equal to these particular numbers because it exists within A. So look, 2, 4, 3, 7 up here. There's 2, 4, 3, 7. And now, even though 7 is inside of B and inside of C, which we'll get to in a later lesson, they're also inside of A because just by its nature, since B and C are inside of A, everything inside of B and C are also inside of A. So now you can kind of get the idea of where we're going with this. We're going to talk about subsets and how to visualize it. And that's exactly what I'm showing you right here. So that's the idea. So let's just go ahead and ask ourselves a couple of questions. I'll pick up the pencil here and let's just ask ourselves a certain set of questions. Pencil. My question would be, is 7... Oh, I'm in the way. Let me jump over to the other side. Is 7 an element of B? You know, it's a question. So here's 7, here's the B circle, and 7 is within the B circle. So 7 is, that's a true statement. You know, is 3 an element of B? So 3 is over here, B is over here. 3 is not in that circle, so 3 is not. So we have to put that little dash through it to say 3 is not an element of B. And that's how that works. It's very simple. So now we can ask ourselves a question like this. Is D a subset of B? So remember what subset means. That means that for every element in D, it'll also be found in B. So let's take a look here. So D is over here. It's got 1 and 0. And B has a 9 and a 7 in it, so no. Everything that's in D is not in B. In fact, that's not a true statement, so again, we'll have to put the little, it's not quite vertical, that angled line through it to say D is not a subset of B. Now, is B a subset of A? That's a question, right? So everything in B is also contained in A. So B contains 9 and 7. A, since A is everything, A definitely has 9 and 7. You can look at it over here too. You know, B is 9 and 7. Is 9 and 7 in A? There's a 7, there's a 9, so yes, that's a true statement. And that's what I wanted to show you, is just how to visualize some of this. Now, let's go ahead and let's make up our own Venn diagram based on the numbers. So let's clear the area here. And let's try this again. Let's just do it a little bit different though. We'll start with the mathematical expressions. So we'll say A is equal to, let's just make it simple though, 3, 6, 8, and 9, and 10, why not? B is equal to 2, 6, and 10. And then we'll just say C is equal to 6 only. So it's very simple. This is going to be a simple one, but that's good. I'll start off with making a great big circle here by hand this time, not with the, well, it's all by a computer, but you know what I'm saying. So there's a circle here. we can probably guess. Okay, it just so happens, I wasn't planning this out, but it just so happens that the 6 is inside of A and B, and the 10 is inside of A, the 6 is inside of A, but the 2 is not. So that's an interesting one, right? In fact, I should have made this a little bit bigger. Maybe I'll do that. Let me go ahead and make it a little bit bigger here. Big giant circle. Now, let's just start putting these numbers down. We'll start with A. We're going to call this A. And we're going to say, okay, the number 3, there's a 6, there's a 8, a 9, and a 10. Now, there's no easy way to do this without just trial and error a little bit. So that's fine. That's A. A does contain all those. Okay, we've got A figured out. Check that one off. Boom. B, 2, 6, and 10. Now, what do they share? Well, there's a 6 and there's a 10. Ooh, but there is no 2 in here. So we have to create some weird looking shape like this. Think about this now. This is not a circle, but this is my container. And the reason why I have this container that's outside of the A's scope or circle is because that number 2 is not in A. So we'll have to throw the 2 out here. Now when you take a visual look at it, that's how it looks. And of course C is also in B and A, because 6 is shared amongst all of them. So we could put C, we can actually do something like this. This is what we should do, is we should circle the 6 and call that C. I should have used different colors for the labels, but I think you get the idea. And that's how you do it. It's very simple like that. Now there's so many more things about sets to learn, like intersections, unions, cardinality, things like that. We'll get into those in later lessons. But what I want to do next is I want to get rid of the circles here and show you how to plot these on a number line. So let me just first delete this mess, and what we're going to do is create the number line first. So remember, the number line is just a simple line, very simple. Boom, I'll just make one up right there. And of course we can put an origin of 0 in there to help us orient ourselves. We don't need the 0. But we need some sort of label to show, where are we starting here? Looking at these numbers here, 0 is close enough to 2 that it's not a big deal. If I put a 0 here, we could still probably get all the way out to 10 way over here. So if this is 10 and that's 0, we can kind of space those out evenly. So let's just kind of actually do that. So we'll say, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And because I have the magic of a computer, I'm going to go ahead and press some buttons I shouldn't. I'm going to go ahead and just delete this part and move the 10 over and pretend that I did it right the first time. Done. Very simple. Okay, so how do we plot these on the number line? Very simple, right? So A is these numbers. A contains a 3. So when it contains a 3, it actually contains it. It's just a dot on the number line. So 0, 1, 2, 3. So we would, and actually let me pick a different color here. So we would actually we'd actually put the dot, hey, that's not the right color. I'm losing it, guys, I'm losing it. Here we go. Try it again. So we put the dot right here. You can see I'm making the mark. So that's the 3, and then a 6, 8, 9, and 10. So 4, 5, 6, 8, 9, and 10. So we have represented the set A on this number line. That's it. It's just those dots. That's all it is. Same thing with B and C. You would just put those dots in. So the B, let's just do a different color because it's different. So the B is a 2, a 6, and a 10. 3, 4, 5, 6. So we're going to put this just above it, but it's actually right on that. It's the same exact position. So 6 and 10. And same thing goes with the C, which is a 6. We'll just do green. 10, 9, 8, 7, 6. So right here, no. 10, 9, 8, 7, 6, right here. But bear with me that these are all exactly on that number line. They're not actually above it, so keep that in mind. Simple as that, right? Now, I have another question. So I'm going to delete these. Let's go back to a blank slate here. And I want to ask you this question and see how we can plot this. So I'm going to put the question up here. I'm going to say, I'm going to say D is equal to a set that contains all real numbers from 2 to 7. And it's in curly braces. It's my narrative, but it's in curly braces. This mathematical expression can be represented. Now, all real numbers from 2 to 7. So to do that, we would actually have to do a line segment, right? So let's just go ahead and I'll do a yellow for this one. So from 2, so 0, 1, 2, we'll put the dot there because it contains 2. And it also contains 7, 10, 9, 8, 7. And I hope you guys understand that that's a 7. You know, these are units of length 1. But it also contains all real numbers. So it contains 2.01, 2.11, 2.5. It contains every irrational number, every single number in existence, infinite amounts of numbers from 2 to 7. And you might say, well, how is there an infinite amount of numbers between 2 and 7? Well, because those decimal places can go on forever. 2.2, 2.2001, 2.2001, and so forth and so forth. So you have to denote that with the fact that this is a line segment that's connected. Simple enough, right? So that's that one. Now let's do a different color, and I'll just do one more example, and we'll call this one quits. Let's do an E, and in fact, let's pick a different color. I'll go back to white. E is equal to all real numbers, I'm not sure of the verbiage here, but bear with me. We'll find the correct verbiage in the next lesson, but I'm gonna tell you this in English, and then we're gonna do it out. So all real numbers between, let's say, 3 and 9, and I'm gonna use this term called, it's going to be inclusive or exclusive. I'm going to say exclusive. And what that is telling me is that it's a way to say, hey, all numbers, all real numbers between 3 and 9, except the exact numbers 3 and 9. See how the difference is? So if I said all numbers from 2 to 7, that contains 2 and 7. Now, when I use the word exclusive, think about excluding something. When you're excluded from the game or excluded from a test, you don't have to take it. It doesn't count. So 3 and 9 are exclusive, as in everything but those. Now, because there's an infinite amount of numbers, so I could say 3 is not on there, but 3.0000000 with 10,000 zeros and then a 1, that is on the number line. But because I can't possibly draw that, we use a different notation for that. And I'll just go ahead and create another number line for us to show you how to draw this out. It's real simple, actually. In fact, I won't create another number line. I'm just going to show you. So I'll make this one an orange color. And colors don't matter. You can see, as long as you can see this and understand my narrative. I understand some people have trouble with distinguishing colors. So you don't need the colors to understand any of my lessons. So between 3 and 9, so 0, 1, 2, 3, there's a 3. I'm going to put this here, but I'm going to draw it down below just so you can see what I'm doing. This is on the number line, but I'm drawing a circle there. Now, you could draw it smaller. I'm just on a computer with, finite resources here. 0 to 9, exclusive, so, 3 to 9, so 4, 5, 6, 7, 8, 9, and that's also exclusive, so it's an open circle. So this line, if it was above, would be right there. It's an open circle. Now, if I didn't say exclusive, it would be a closed circle, a solid one like the one you see here. So 0, 1, 2, 3, 3 to 9. So it's going to look like that once it's on top of it. In fact, I'll leave it up there. Now, if I said something like all real numbers between 3 exclusively and 9 inclusively, you would have that one circled in, right? You'd have the 9 circled in. And that is pretty much it. So if it was inclusive, it would be just a regular dot. Exclusive would be this. One thing that we'll do is explore a lot of sets throughout the entire algebra course. So don't worry about it if you don't quite get it yet. I'll see you in the next lesson.